Welcome back to the Explainer, everyone. Today, we are absolutely decoding the elements. You know, if you've ever stopped to think about the literal building blocks of the world around us, like the air you're breathing, the ground you're walking on, or even the screen you're looking at right now, it literally all boils down to elemental action. So let's just strip away all the crazy complexity and review exactly what an element is, step by step. Part 1, defining the element. Okay, let's dive into this. So an element is a pure substance made up of only one kind of atom. I really want you to focus on those two specific phrases here, pure substance and one kind of atom. This isn't some messy mixture or a blend, you know? If you've got a true element on your hands, it is entirely pure. It contains literally only one specific kind of atomic building block. But honestly, that brings up a pretty crucial question. If an element is just one kind of atom, what does one kind of atom actually mean in practice? Like, if you're looking at things on a microscopic level, how do we actually differentiate between one tiny building block and another? Part 2, unlocking the atomic number. To solve this little mystery of what makes atoms identical, we've got to uncover a secret code. And that code is this: same atomic number equals same kind of atom. This is your definitive identifier, guys. If you want to know if two atoms are perfectly identical, you don't go looking at their size or how they're behaving right now. No, you look for this one intrinsic value, because if the atomic number matches, the atoms match. End of story. But wait, what exactly is the atomic number, right? We know it acts like this ultimate ID tag, but what is it actually measuring? Where do we even find this secret number? Well, get ready for the big reveal. The atomic number is simply the number of protons located right there in the nucleus of an atom. That is it. It's literally just a simple head count. You count the protons hanging out in the center, and boom, you have the atomic number, which tells you exactly what kind of atom you're dealing with. Now, as you probably know, atoms naturally love to be balanced. In a standard neutral atom, you get this absolutely perfect matchup. The number of positively charged protons sitting in the nucleus is exactly the same as the number of negatively charged electrons buzzing around the outside. It's this beautiful, perfect numerical symmetry that keeps the neutral atom totally balanced and stable. Part 3, the boron case study. Let's look at a specific piece of evidence and see this rule in action. 5. That's it. That single number tells us literally everything we need to know about our case study today: the element boron. Every single atom of the element boron has exactly 5 protons in its nucleus, which means, by definition, its atomic number is exactly 5. Listen, if it has 4 protons, no way, it's not boron. If it has 6, absolutely not boron. Boron is completely and totally defined by the number 5. And following that rule of balance we just talked about, this also means a neutral boron atom has 5 protons in the center and 5 matching electrons dancing around the outside. Because they all share this exact same proton count, they are all definitively, unmistakably, the exact same kind of atom. Just think about the uncompromising scale of this rule for a second. It is honestly awe-inspiring. Whether you have just one lonely little boron atom sitting in a vacuum, or a massive clump of literally 1 million boron atoms, every single one of them has an atomic number of 5. That unwavering consistency across the board is exactly why boron earns the prestigious title of an element. Part 4, the elemental lineup. Now let's do a rapid-fire look at how changing this secret number changes the whole shebang. And this brilliantly illustrates exactly what we're talking about. Look at this lineup. An atom with just one single proton has an atomic number of 1. That's hydrogen. Now, give an atom 6 protons, the atomic number jumps to 6, and suddenly you have carbon, which is literally the foundation of life on Earth. Add 2 more protons for a total of 8, and you've got oxygen. This incredible, mind-blowing diversity of our entire elemental world basically boils down to simply counting protons. Part 5, the secret identification formula. Let's synthesize all the clues we've gathered so far into one unified code. All right, here is your ultimate 3-step checklist that proves exactly what an element is. Step 1, it absolutely must be a pure substance. Step 2, it's got to be made up of the exact same kind of atoms. And step 3, the definitive test, every single one of those atoms must share the exact same atomic number, which means they have the exact same number of protons in their nucleus. And that's it. That is the secret to identifying an element. We cracked the atomic code together. By understanding that elements are just pure substances defined by a strict, unyielding proton count, you honestly have a super solid grasp on exactly how matter is categorized in our entire universe. But as you know, answering one question in this explainer always just opens the door to an even bigger one. So here's a little something to chew on. If protons perfectly and rigidly define an individual element, what in the world happens when atoms with completely different atomic numbers crash into each other and combine? Do they create something entirely new? I really want you to think about that, because that is exactly where our journey is going to take us next time. Keep questioning, keep learning, and I'll catch you in the next explainer.